Okay, so first we have 6 fair dice, and we want to know the probability that at least one, we get at least 1 6 when we toss 6 fair dice. The second, at least 2 6s. The third, at least 3 6s. Supposedly it's called the Newton-Pepys problem. It is a nice problem, in my opinion. So how should we go about doing this? So you could write down all possibilities for 6 fair dice, right? How many possibilities would we have? 6 to the power of 6. Do we really want to do that? No, that's what, 900 times, that's like 27,000 outcomes approximately. Too many. We can't do that. So we have to do some things easy. All right. So anytime you see at least, you should automatically think of the complement, specifically when it is at least 1. So in terms of count, if we have the 0, 1, 2, 3, 4, 5, 6, dot, dot, dot. No, I'm just a generic case. I'm not going for this case. Generically speaking, that would mean at least 1. Do you agree? So if I call that to be event A, what is the complement of event A? 0. Getting 0, right? Yeah. Why do you sound so morose?
Allergies.
Oh, sorry to hear about that. So that would be the complement of A. So if we want to find that, we could actually use its complement, right? So the probability of at least 1 6 would be equal to 1 minus the probability. What does 0 mean? No 6s.
Yeah.
So we have 6 dice fair in the sense they don't magically stand on the side, or after you roll the dice, they don't catch on fire. So they work properly. That's what we mean by fair dice. So what is the probability you get no 6s? Huh? 5 out of 6. Well, that is for 1 die.
Yeah.
I've got 6 of them. Now, what method did I teach you? Or I gave you, if you do this, you can understand probabilities better. What's that? Nick, right? What? Huh? Andrew. The dashes and the dots. So 1 minus, we've got 6 of them. Right? What is the probability of no 6? What was your name? Macy. Macy or Casey? Macy. So that is 5 out of 6 for the first die. Do we agree?
Yep.
And likewise, 5 out of 6 for the second die. Do we agree? 5 out of 6 for the third die. 5 out of 6 for the fourth die. 5 out of 6 for the fifth die. Running out of space. 5 out of 6 for, I mean, you got that to be the complement. that's what we have. Are you with me so far? Now, oftentimes, well, we want to know, we've got 27,000 something outcomes. We want to know if there is a possibility something else might show up. Well, so we have to ask the number of ways in which I'll call that a complement can happen. You should always pay attention to that, or else you're just getting, part of the probability, not all of it. So in how many ways can a complement happen? Is it not? Huh?
Just one way, right?
Yeah. But is it or is it not?
I would say it's only one way.
Okay, good. Good. Nathan, right? What do you think? Nathan, I got the same thing. So 1 minus 5, 5 over 6, raised 6. It could happen exactly in one way. So I'll put that here. Right? I'm asking no 6s at all. So that probability ends up being 1 minus 5 over 6 raised 6. You can use your calculator and tell me what you get. So there is a 66.5% chance that I would get at least 1 6 if I tossed or rolled 6 paradise. Does that make sense? Okay. Yes, we can erase this, right? Did you guys write this down?
1 over 2 over 2.
I'm going to give you a few minutes to try part B, but how would we go about doing this? I'll give you a hint. So probability of at least 2 6s, and we are rolling 12 fat dice. We've got 12. So how many possibilities would we have in total? 12 dice. So what are all the possible outcomes? Six raised 12, right? The first one's got 6 possibilities, second has 6 possibilities, and so forth. And is it done with replacement or without replacement? With replacement, because just because the first die resulted in a 2 doesn't mean the other dies couldn't have a 2. So the numbers, they do get replaced. Are they independent? Yes, one die doesn't affect the other, which is why we are simply using the fundamental rule of counting and multiplying them together. Okay. In a problem like this, I always recommend doing what I did over there. 0, 1, 2, 3, 4, 5, 6, at least 2. I'll call that event big. So that is my hint. Give you a few minutes. Let's see if you can get that box. So pay attention so that you can try the third one. So at least 2 6s. I have event B. The complement of that event is that, right? As I went around, some of you took, I'll call it C1 and C2. Some did the C1 intersection C2 to be the complement. That would mean both 0 happened and 1 happened. Well, that's not true. Either 0 could happen or 1 could happen. so that has to be a union. So if I call that event B, that would equal to 1 minus the probability of B complement, which would be equal to 1 minus the probability of C1 union C2.
Yeah.
Is it sticking somewhere? Where did I put that?
What's going on?
I erased it, it's right here. Okay. So what is, well, what rule should we use? It's C1 union C2. 1 plus C2.
C1 plus C2.
Just, oh, probability of C1, yes,
Yeah.
plus probability of C2.
Yeah.
But what about the last part? You left that out, Peter. Huh? Now, could you have no sixes when you roll 12 fair dice, and exactly 1 6 when you roll 12 fair dice simultaneously? That's what this means.
No.
Can't happen. So C1 and C2 are what type of events? Disjoint. And disjoint events have another name. You guys have to read, people.
Mutually exclusive.
Thank you. Mutually exclusive events. The occurrence of one would prevent the occurrence of the other event. So they are mutually exclusive events. If they are mutually exclusive, that probability would simply be 0. Now we want to find the probability of C1. No sixes because it is a complement. C1 means no sixes, 0 sixes, and we have 12-sided dice. We don't want to, write, sketch all 12 lines. How about this? Number of ways in which C1 can happen.
I think it should be 12 there.
Multiplied by the probability of no sixes. Right?
Yeah.
Now, no sixes would simply mean probability of an individual one would be 5/6. Yes?
Yeah.
And it's a 12-sided die, so 12 fair dice.
12.
Oh, I said 12-sided, my bad. 12 fair dice. In how many ways could you have no sixes at all? I'm not asking for the probability. Number of ways.
I'm sorry. Oh,
One way, right?
Yeah.
Just like the previous problem. So
Yeah.
1. And the probability of that would simply be 5/6 raised the power of 12 because we have 12 spots. Does that make sense?
Yes.
So that is C1 or probability of C1. Are we done yet?
No.
No, we've got another bit, when probability of C2, which would mean probability of exactly 1/6 And we're rolling 12 fair dice. Now this is kind of tricky. We're going to do the same thing. The number of ways and number of ways for C2 to happen. We're going to multiply that by the probability. But some might know this already, and some take some practice. Drawing this helps. Right. So I have 12 dice. Those are the outputs. Let's say I fix a position. I'm going to fix the 6 happened right here. Right? So if I fixed right, we know that is 30 because 6 happened here. Now all of these will have different permutations that we can think of, or different combinations of numbers. So, in how many ways could that happen? How many spots do I have left? 11. So the probability here would be 11 over 12.
5 over 6.
5 over 6 here, 5 over 6 there, 5 over 6 there. So we would have 5 over 6 base 11.
Yep.
Right? Here is another question. Is that the only way for it to happen?
No,
Why not?
there are 12 ways that 6 can be.
There are 12 places. So to move this x, correct. So I could either have it here, or there, or there, or there, or there. So you have 12, and you have to pick one spot out of those 12. So what would you use to compute the number of ways? Do you want me to repeat? Dennis, what's up?
Choose function.
Choose function. Okay, so 12 spots, and we've got to pick one. So how many ways could we choose using the choose function? 11. 12 choose 11?
No.
12 choose 11 would mean you leave that blank and you're choosing all of these. Oh yeah, you talk about, yeah, never mind. I see what you do. Never mind. They are symmetric. He can't. I was going with it. He's correct too. He's talking about symmetry. They are symmetric. Good job.
Oh, that'd be right.
So if this would be 12 choose 1, right? In 12 sports, you pick 1. It is the same as saying 12 choose remaining 11, as they are symmetric. Took a second. I'm getting lost. Okay, so the number of ways for C2 to happen would be, what is 12 choose 1? You can use your calculator. 12 ways.
Yeah. There you go. Sounds good.
No, you see, 1/6. Yeah, okay. What is that equal to? 0. Huh? So, I mean, that 12 comes here, right? If you fix, that probability is 1/6. That's what I mess up. So 1/6 multiplied by 5/6 base 11 is 5/11 divided by 6 base 12. It's not 1. Okay. But still, even if we're fixed, it's not certain. It happens with the probability of 1/6. My bad. So what does that equal to?
0.269175979.
269. Okay.
I mean,
What is this equal to?
Okay, so like five. 5, 6.
-0.112.
112. So our final probability is 1 minus 0.112 plus 0.2691. And what is the total?
0.381.
Okay, so 1 minus 0.381.
Wait. Oh, yeah, that is it.
619.
Yeah.
I see, I messed up. Still, it's 1/6 comes out. I would like to know, how this goes. Now, as you explain stuff, if you made a mistake here and there, that's okay, right? But at least I need to know that you can explain things properly. So same process, so 0, 1, 2, 3, 4, blah, blah, blah. And we'd like to know at least 3, 6, so 3 above. I will call that E. So what is the complement of that? So we'd like to find the probability of E complement, which is the probability of either you get 0, I'll call it D1, that's D2, D3. Good. So you'll have probability of D1, union D2, union D3. Because those can't happen simultaneously, this or that. So union. What rule should we use to find that probability? Addition. Addition rule for 3 events. So that is probability of D1 plus the probability of D2 plus the probability of D3 minus the probability of D1 intersect D2. What is the next sign? Plus the probability of D2 intersect D3. The next one, minus probability of D3 intersect D1. I'm maintaining this, D1 intersect D3. I'm maintaining this order because of the inclusion-exclusion principle. We always write it as I less than J. Good. What is the last term? Okay, what is the probability of D1 intersect D2?
Excuse me, shouldn't it be minus the probability of D2 intersect D3? You can only stop sign once you include an additional element or an additional figure.
No, minus plus minus plus. That's correct.
But it's in groups of 2, it should be minus all those plus all groups of 3, then you go minus all groups of 4, etc., etc., etc.
Wait. We group them together. N plus 1. Should I? Minus 1 is 2 plus 1. That's 3. So it's the plus plus plus. All of those are minus, and that's n plus 1. N is 3, it's not 2. Okay, so that should be minus. And now that's plus. Okay.
So it's subtract all the 2s.
Yeah, and then you add the 3s, subtract the 4s, add the 5s, and so forth. What happens to that, and that? they're all disjoint, right? These two can't happen together.
It is.
Those two can't happen together. Those two can't happen together. All three cannot happen together. So they're all zero. They're all mutually exclusive. So 0, 0, 0, 0. What is probability of D1? Well, easier way to do this. Well, we won't know sixes. Well, it could only happen in one way, right? Exactly one way. And I could write this as 18, choose 0. Yes? No sixes. So all of them are something else. So 5/6 raised 18. Probability of D2, most of you got this part because this is similar to the previous one. If you have 18 dice and we want to pick one, so first step is to choose one position out of those 18. And in how many ways could that happen? That is 18 choose 1. What is the probability of that chosen place? 1/6. The remaining can't be 6, so 5/6 raised 17. Yes? Lastly, probability of D3. In how many ways? Well, let me draw this one because some of you made a mistake. So 1, 2, 3, 4, all the way up to 18. So the first possibility, let's say I put those two. And that would give me 1/6. 1/6. Right. What about the remaining? I took care of 2 positions, which would mean there are 16 left. So all of those cannot be 6. So that would be 5/6 raised 16. Right? Now, what is another possibility? I could move this and write it as XX. Right? That is also a possibility. I could move this again and write it as XX. That is also a possibility. I can move this and write it as XX. Also a possibility. So how do we find the number of ways? Well, you think of having 18 boxes, and you've got to pick 2 boxes to put a kitten in each, right? In how many ways can you do it? 18 distinct boxes, 2 kittens. That is 6. 18 choose 2. Either I can choose the first 2, or I can choose the first and the third, or I can choose the third and the fourth, or I can choose the last 2, and I can keep on doing that. So the number of ways would be 18 choose 2. So 18 choose 2, 1/6 squared, 5/6, right? 16.
What happens if we go like 5 to the 17 over 6 to the 18? Then that would be
You multiply those together.
6 raised 1, 6 raised 17, and 6 raised 18. So this would simply be 18. 18 choose 1 is 18. 1 times 5 raised 17 is 5 raised 17. 6 times 6 raised 17 is 6 raised 17. And it's the same here. 18 choose 2. If you put it in the calculator, it is 153. So 1 squared is 1, 1 times 5 raised to 16 is 5 raised to 16, divided by 6 squared times 6 raised to 16, 6 raised to 18. Add them all together, you would get the probability for part C. So the probability of at least 3 6s,
The probability of
you roll 18 dice. What do we get?
1 minus some of those.
Yeah, 1 minus the sum of those. And
Yeah.
what is 1 minus the sum of those?
That's 403.
597.
Take a look macro. Oh, no, yeah, okay, so that's, yeah, no, that's
You're
that's
gonna
the
go-
sum after the actual total, okay. That's what I got. After the subtraction.
Okay, what did you get?
2597.
So approximately 60%. So which one has the highest probability? First one?
One minus. Can I put that probability?
Which makes sense, or which should make sense, right? The more dice you have, the harder it's going to be for us to get like exactly 3 6s, or because we're saying, or excuse me, at least 3 6s, or at least 4 6s, and so forth. Are we clear with this? So this is what we call a Newton-Pepys problem.